What is center of gravity? Center of gravity is a point in an object at which the weight of an object, the whole weight of the object appears to act. Let's say there is a sphere or ball. So the center point would be inside the sphere at the middle. Usually, it is easier to find center of gravity of regularly shaped objects. For example, for this circle, to find center of gravity, we need to see the symmetric lines. If we find two symmetric lines and the point at which they intersect, the point of intersection is the center of gravity. Let's say for this circle, this is one of the line of symmetry and this is another line of symmetry. So the weight of the object, weight of this circle would act at this point, from this point. So this is the center of gravity for this circle. Similarly, for this rectangle, if we find two lines of symmetry, this is the center and the weight will appear to act from this point, and this is the center of gravity. For triangles too, if we find the lines of symmetry, two lines of symmetry, it's the center point, so it's the center of gravity for triangle. But a problem might arise if the object is irregularly shaped like this one here. So for that, we need to suspend the object using a string. We can attach a string to this object here. It's a single plane, let's say paper, but it's not a rectangular shape. Its shape is like this. So for that, we can suspend the this object using a string. After suspending the object at this point using a string, let's say due to turning effect, the object will start to move, but at some point it will balance when the weight force acts along the center of gravity. That is when the object will balance. So let's say the object will balance in this position. So we can say that the center of gravity is somewhere along this line. If we attach again, remove the string from here and attach the string in this position, and we would get something like this. The object would again balance, would turn, move and balance at a position where the center of gravity weight acts along the center. So earlier we get the line as like this, and now we get the line as like this. When we get this point, when we get a balance in this position, we should use a scale to draw a line here. After that, we can suspend the object again at this point using a string, and we should again use a scale ruler to draw the line. That means the center of gravity acts at this position, somewhere around this position. Okay. So center of gravity is related to stability of objects. An object, so let's first know what is a stable object. A stable object is one that is less likely to fall over if it's tilted or moved. That means if the object is tilted, it will be more likely to return to its original position. So here I have shown two cases, an object with small base and another object with a wide base. Now we will see why objects with smaller base are less stable and objects with wider base are more stable. So this is the weight force acting on this is the center of gravity, and the weight force is acting from this point. This is the contact force from the ground on the object that is balancing the weight force. So there is no resultant force on the object, and also there is no turning effect of force. That means the object will be in equilibrium. But let's say we apply a force like this and tilt the object, and we get a situation like this where the weight force did not pass the base. The weight force is acting on the base, acting from this point, but it does not pass over the base like here. This is the base, this is the base. Here the weight force have passed over the base, and here the weight force haven't passed over the base yet because there is less tilting. So here we can see as the weight force have not passed over the base, that means but there is a turning effect of force. The object will move in this direction. This is stable. Comparing with this object is less stable. We will discuss that later. Let's just focus on this first. So after tilting the object at an angle of this, the object will move back to its original position, this, when the weight force does not pass over the pivot or the base. This is the pivot now. As the weight force is acting on the left of the pivot, so there will be anti-clockwise turning effect, and the object will be like in this original position. But if we have tilted this same object more, the tilting angle here is less than in here. Here the tilt angle is more. Here what happens is that the weight force, the point from which that weight force is acting has passed over the base. Now if we remove the tilting force, like the person who applied force here tilt the object will not return to its original position like here. It will fall over. It will fall over and be like this and become like this. So if it was a glass, it would have broken down. So it is more favorable that objects have wider base. because here this is another object with wider base, because this length, when this length is compared to this length is much bigger. When this same object is tilted at the this object is tilted at the same angle at which this object is tilted, this would also return to its original position, this position. So because the weight force acting from this point, and this force hasn't passed over the base yet, so it will return to its original position. Here we have tilted this object too much. It's let's say this angle was around 45. Let's say this angle was 45 degree, but here it is clearly visible this angle with wider base is tilting at a point that is much greater than this angle, tilted at an angle that is much greater. So let's say it's tilted at a 60 degree. I've used the angles just for easy understanding. So here we can see that the weight force has already passed over the base and it will fall over. So comparing with this object needs to be tilted more to fall over. So an object with wider base have more stability. Also here as the center of gravity is somewhere around this point, so the height from the ground is less, so center of gravity is acting at a lower point, but here the height from the ground is more. I'm denoting with capital H as it's the height from the ground is more, so the center of gravity is at a higher point. So we can also conclude that objects with lower center of gravity and wider base are more stable than objects with smaller base and higher center of gravity.